Hi there and welcome to our next video on some exam questions related to electrolysis. Our first exam question states, a student dissolved some potassium chloride in water. The student tried to electrolyze the potassium chloride solution to produce potassium. The apparatus in the student, the apparatus the student used to shown is shown in the diagram. The student expected to see a potassium metal at the negative electrode, but instead saw bubbles of gas. Name the gas produced at the negative electrode and explain why this gas was produced at the negative electrode and why potassium was not produced. The reactivity series of metals on the chemistry data sheet may help you to answer this question, and it's worth 3 marks. So first of all, we have potassium chloride. Now, because it's dissolved in, that means we have other ions as well. We have H plus and OH minus. Okay, now potassium is really reactive, and the rule at the cathode is that the either hydrogen, copper, silver, gold, or that's it. That's all that can be formed at the negative electrode in a dissolved solution. So potassium is too reactive. So name the gas produced at the negative electrode is going to be hydrogen gas is produced at the negative electrode. Okay. Explain why this gas was produced at the negative electrode and why potassium was not produced. And this is because potassium is more reactive than hydrogen. So hydrogen will be attracted to the opposite charge. Hydrogen will be attracted as opposites attract, and that will get you 3 marks. Now the next question, the student tried to electrolyze molten potassium chloride to produce potassium. Potassium metal was produced at the negative electrode. Describe how potassium atoms are formed from potassium ions. So potassium ions, potassium is in group 1, so it has a charge of positive, and so it will need to gain to form an atom. So it loses an electron. So potassium loses an electron to become the potassium atom. Okay, and that will get you 2 marks. Cans for food and drinks are made from steel or aluminium. The main metal in steel is iron. Reacting iron oxide with carbon produces iron. Draw a ring around the correct answer to complete the sentence. The reaction to produce iron from iron oxide is what? Decomposition, oxidation, or reduction. So iron oxide, well, iron is going to be attracted to the negative electrode, and so the answer is going to be reduction. Okay, 1 mark. Aluminium cannot be produced by reacting aluminium oxide with carbon. Why does aluminium oxide not react with carbon? Take 1 from the box. Aluminium is less reactive than carbon. Well, that's obviously not true. It's more reactive than carbon. Carbon is less reactive than aluminium, or oxygen is more reactive than aluminium. The correct answer is that carbon is less reactive than aluminium. 4 mark. Next question. Aluminium can be produced by electrolysis. Why do the aluminium ions collect at the negative electrode? Again, opposite charges attract. So opposite charges attract. So aluminium 3 plus will be attracted to the negative electrode. Okay, 2 marks. Next question. Aluminium is extracted from aluminium oxide using electrolysis. The diagram shows a cell used for the extraction of aluminium. The electrolyte contains cryolite. Explain why. Now, cryolite is used to lower the melting point is to lower the melting point of aluminium oxide, so they can be used to be extracted. Okay, and that would get you 2 marks. Next question. Oxygen is formed at the positive electrode. Complete and balance the equation for this reaction. So O2 is going to add to, each one is a 2 minus, so it's going to add 4 electrons over here, and to balance that out is going to be 2 O2. Okay, 2 marks there. The positive electrode in the cell is used up during this process. Explain why. It's because the oxygen formed at the anode reacts with the carbon electrodes. Okay, and that's all you need to really say for those 2 marks. Okay, and that is it for this video. Thanks for watching. I hope you liked it, and one last thing, please subscribe, hit the like button and the notification bell.